Chalo, everyone can hear me? Everyone can hear me? Hello, Meet. Okay. This time from the starting only I wanted. How many is live? That many likes I want from the starting itself. I have liked. Okay, chalo. So I will come in front of you. Chalo, everyone can see me now? Okay, hello. Atif Ali is over here, Sakiruddin, then Mishri is here, Tulsi, Hetan, Swasti, Bhakti, Marvin, Mahi. Who is this? Deepti Sanghvi. Can you drop the name, please? Kriti is here. Oh my God, Kriti is here. Mayor Daksh is here. Neev is here. Good. Good morning, everyone. Good morning, Archie. Okay, Om Gondalya S Kitchen. Okay. Rushil is here. Good morning, everyone. So, everyone get ready with the pen and book so that we could start. Yes, 29, 31 are there and likes are only 24. Make it fast. Like 25 likes, 31 views, 25 likes, fast. Yeah, okay, Iya is here. Okay, chalo. Now, without wasting any time, we will see that what are our plans today. So, first of all, we are going to go with our chapter 1, then chapter 2, and then chapter 3. In today's 1.5 hour session, right now our plan is with the chapter 3, chapter 1, 2 and 3. Our chapter 1 is what? We all know, rational numbers. Then chapter 2 is what? Chalo, drop the message fast. Chapter 2, name of the chapter 2 is what? Fast. What's the name of chapter 2? Linear equation. Yes, linear equation in one variable. And linear equation. Chapter 3. What's the name of chapter 3? Yes, everyone. Rushil, linear equation. Sangvid, yes, linear equation in one. Very good. Sekaruddin is the first. Understanding quadrilateral. Very nice. Understanding quadrilateral. Mahi nice. Swasti nice. Understanding quadrilateral. Very good. Chalo, Om Gondalya, Kreet, Man, everyone nice. Sarna nice. Meet. Good. Tir, Tulsi, Atif, Riddhi. Chalo, now today without wasting any time, first of all we are going to learn that what is a rational numbers. When we come to the point rational number, then we had learned from the lower grades, we have learned many types of numbers, like we had learned whole numbers, natural numbers, then integers we had learned, then we have learned rational numbers. So how these all are interrelated to each other, this is very important. So if I come to the point, first of all we had learned that there are the natural numbers. First of all we had learned that there are natural numbers. Yes or no? Can anyone drop the message fast? What are called the natural numbers fast? Let me check out your basic concepts. What are natural numbers? Fast everyone. What are natural numbers? Rational numbers means, okay, natural. Hetansh is telling 1, 2, 3, 4, 5, okay. Then 1 to infinity, okay. Mai is telling 1 to 10. Jainam, it's wrong. 1 to infinity, okay. 1, 2, 3, 4, continue. Whole numbers, okay. 1 to 5. That means all of your basics are clear, right, Tirth? Once is here, Yugi is here, Atif Ali is here. So which numbers that comes after 0 are called the natural numbers? Atif Ali says that. Man, whole number, very good. Chalo. So let us see. Natural numbers are what? That the numbers which start from 1, 2, 3, 4 and continue. Same way if I talk about whole numbers, then what are whole numbers? Whole numbers, drop the message fast. What are called whole numbers? Because right now I am going to make you draw a diagram of all the types of numbers which we had came through. Sekiruddin, 0 to, okay, Swasti said 0 to infinity. Kriti is saying 0 to infinity. Meet, Tulsi, Man, Vans, everyone nice. Hetansh, yes, Gondalya Om, very nice. Chalo. Everyone is saying 0 to infinity, 0 to infinity. That means natural number starts from 0, 1, 2, 3, 4, 5, but it goes to the infinity. Same way if I talk about what are integers. Who will tell me what are integers? Fast. What are integers? Fast everyone, students. What are called integers? Let's see who is the first to answer. Quickly. Yes, Man is the first to answer. Integers are numbers expressed in full. No. Positive, okay, that's right. Positive, negative, then plus minus sign, then negative, 0. Krit, perfect answer. Negative, positive and 0 numbers. Then Mahi, right. Positive, negative, everyone right. Minus, plus, positive, negative. Good. See, not only positive, negative. Integers means all the positive numbers, all the negative numbers, more over 0. These are called rational numbers. These are called integers. Now when we come to the rational numbers, now what is rational number? Can anyone tell me what is the rational numbers? Meet, which includes both whole number and natural number, okay. P by Q form, Swasti is saying, okay, P by Q form. Then expressed as P by Q fraction. Sir, I am late, but good morning, Vishwam. Good morning, Vishwam. Then P by Q, Bhakti answered, Swasti, Man, yes, everywhere. So rational numbers are such numbers which are represented in the form of P by Q. Now in this, all the positive numbers, all negative numbers, and 0 will include, but the condition is that Q should not be equals to 0. There is one condition, that rational number means which is represented in a form of P by Q, where all the positive, all the negative numbers, moreover the 0, everything is included, but Q should not be equals to 0. And what's the logic behind it that Q should not be equals to 0? Because we know that if I write 1 upon 0, then the answer would be, what would be the answer if I divide 1 by 0 then? What would be the answer if I divide 1 by 0? 0, no, wrong, Marvin wrong, Atif Ali wrong, nothing, okay, Man said nothing, not defined. Swasti is the first to answer, not defined. Then Krit, yes, okay, then infinity would not be there, no. Right now I only got 3 answers. Not possible. It is possible, but it is a certain term, not defined. Marvin said not defined. Then Krisiv Faldu said not defined. Very good. So we know that 1 upon 0 is not defined. The simple reason which I explain you that if let us just understand such a way that if I divide 1 with 0, that means I have to divide 1 with 0, and we know that for an easy trick I told you that the 0 does not have its table. So if 0 does not have its table, then we can say that the answer does not come. So that means when 1 is divided by 0, then the answer is not defined. But yes, on the other hand, if 0 is divided by 1, then definitely the 1 has its table. This is the way which I taught you. The 1 has its own table. That means the answer is 0, because in one table when 0 is coming, zeros are. This was the actual thing which I had explained you, and this is very common mistake which you all are making, that the 1 divided by 0 is 0, but no, the answer is not defined. The answer is not defined. This is the very easy trick which I had explained you to learn that 1 upon 0 is not defined, whereas 0 upon 1 is 0. Is it clear to everyone? Yes or no? Okay, chalo. Then if you want to write it, quickly write down in your book, so that this would be very helpful to you in the higher grades also when they have been told you to find. Yeah, many times it is asking the question also that are all the natural number a part of a whole number? This question is asked. So I will ask you a few questions on this topic, so don't worry. Just quickly write down. And right now the 50 viewers are there, but there is one thing, that likes are only 39. So those who haven't liked it, please hit the like button and enjoy the crash course part 1. Quickly like. I want 50 likes, complete 50 likes. Chalo. Fast, fast, fast. 40 likes we reach. 43. Yes, fast. Still many of them are not there in the live sessions I told, but so how many parts of the crash course are there? Right now I am thinking that we should go with the 2 parts, but let's see what happens. There are 49 viewers and 45 likes. Still 4 are there who haven't liked. Like the hit button and write. And once you complete writing, just inform me so that we can move further. Sir. Chalo, now few questions to be asked on this. That let us start with the question answer round. Everyone get ready. Everyone get ready with your comment sections. I will be asking you few questions from this, and why I have made you this table you will come to know right now only. Chalo, everyone ready with your comment sections? Let's see who is the first to answer. Yes, chalo. Now, the first question to you. Can I say that all the natural numbers are whole numbers? Can I say all natural numbers are whole numbers? Yes, Tulsi is the first to answer. Man. Okay. Very much. Yes, Detroja is there. Zarna. Then Sekaruddin. Arya is here, then Faldu is here, Rushika is there. See, most of the students have commented yes, but actual answer is yes. Few of the students have said no, but the answer is wrong. Why it is wrong? What I said, that all the natural numbers are whole number, then definitely our natural number starts from 1, 2, 3, 4, 5. And whole number starts from 0, 1, 2, 3, 4, 5. Then definitely all the natural numbers are a part of a whole number, definitely. Clear? So that's the only reason why I make you draw this table, so that you can answer this type of silly questions in your paper if it's been asked, and you simply lose your marks due to this all silly mistakes only. So definitely the natural number starts from 1, 2, 3, 4, 5, 6 and the whole number starts from 0, 1, 2, 3, 4, 5. That means definitely all the natural numbers are whole numbers. Clear to everyone? Now next question. Get it ready. The next question. Are the decimal part of integers? Yes or no? Are the integers part of, are the division part of integers? No. Pranav said no. Pranav is the first to answer. Then Faldu, yes. Swasti, yes. Zarna, yes. No, no, no. No, no, no. Etans, no. Everyone is saying no. Bhakti, no. Yes. Only Anushka says yes. And Mishri says yes. Marvin says yes. But actually the answer is no. I explained in the class also. I explained you in the class also that decimals and the fractions are not a part of integers. Decimals and integers are not a part of integers. Why it is not a part? Because fractions comes under rational numbers. So when I say that decimal and fraction are a part of integers, then definitely the answer is going to be no. One more question to you. When can rational number be 0? When can rational number be 0? When can rational number be 0? Fast. I want no. When can a rational, when it is, when there is 0 upon 1, okay, 0 upon q. When it is in numerator, definitely Meet said first. Then when it is in numerator, okay. Then when p is 0, good Krit. Q is not 0, Hitanshu. Then Bhakti was 0 upon 1, okay. Atif Ali 0 upon q. When it is divided by 0, Man, that's wrong. When it is divided by 0, then it will become not defined. 0 upon q, definitely. Okay, when the numerator is 0, okay, 1 by 0. Tulsi, it's wrong. 1 by 0 means it will be like this and it is called not defined. Okay, when numerator is 0, great. Everyone, most of them are clear with this. That 0 upon any number, Soumya said. Very good, Soumya. When there is 0 upon 1, q is not 0. Okay, numerator. Good. Now see, from here, this type of questions can be framed. Even one more question is asked. Are the natural number a rational number? Are the natural number a rational number? Yes or no? Are the natural number a rational number? Yes. Krit said yes. Meet says yes. Vishwam said yes. Then Swasti said yes. Arya said yes. 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 Hetan said yes. Mahi said yes. Okay. Okay. Yes, they are. Hetan said. Okay. Sekaruddin yes. 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 Detroja said yes. Soumya said yes. Definitely yes. Why it has been? Because rational number includes all the numbers, all the positive numbers, all the negative numbers and all the zeros and everything. So that means definitely rational number is also a part, natural number is also a part of a rational number. Clear everyone? So chalo, if you have written, then I will erase it and we will move towards further concepts of chapter 1. See, these are very few basic questions asked on the rational numbers and where we definitely failed to give the answers of that and we lost our marks. So that's the only reason. Now we will look the properties of it very quickly and we will talk about few concepts, and more important is, rather than talking about the properties, the more important is that we should know when these properties are used. That is more important. If I say that in the rational numbers we are having 4 categories under which all the properties exist. Like first property is addition, first, then subtraction, multiplication and division. These are the few properties which are, these are the few topics under which all the properties exist. Like properties which exist, that is closure, commutative and associative. Now I am not going to teach you the identities A, B, C, whatever it is that. Today we are going to learn it somewhat in a different manner. Like if we see that addition, subtraction, multiplication and division, in that there are the two friendship, that is, which are that friendship? Addition and, which are the true friendship? Addition and, answer it fast, addition and, fast. Addition and multiplication, Adesra says first, okay. Addition, multiplication, Kreet, multiplication, yes, Zarna, multiplication. So addition and multiplication are the two friends, you can say, addition and multiplication. Same way the another true friendship comes, that is what? The true friendship that comes, that is the subtraction and subtraction and division. Kreet was the first to answer, good Kreet. That is subtraction and division. Why we say that they are the true friends? There is a simple logic to say behind that, is only that because whichever properties are applicable or gets right or satisfied with the addition, same properties would be satisfied with multiplication also, as well as the properties which does not satisfied with the subtraction will also satisfied with the, will not satisfied with the division. Simple thing is that, for example, if I say that I can add the numbers in any order, like if I say, if I add 5 plus 4 or 4 plus 5, definitely what is that my answer is going to be same. I can add the numbers in any order in addition. Same way in multiplication also, I can multiply the numbers in any order, like if I say 5 into 4 or 4 into 5. Getting my words? I can multiply the numbers in any order. I can say 10 5s are 50 or 5 10s are 50. Any order I would say, then also the closure property would come. But in the subtraction it is not so. Can anyone give me the examples of the subtraction? Fast. Can anyone give me the examples of the subtraction? I want an example. I don't want yes, no. I want the examples. A, B, C, D कुछ नहीं चाहिए मुझे. 5 minus 4, Kreet is saying, which is 4. Okay, Kreet. 6 minus 5, 20 minus 1, Swasti is saying. Okay, 1 minus 20, definitely. Then my 1 minus, Kreet said, everyone is saying, yes. 3 minus 1 is 2, 5 minus 4 is 1. But same way, yes. So Mahi, it is said that 2 minus 1 अगर आप करते हो, then you will get the answer 1. But definitely 1 minus 2 is not going to be your answer, because अगर मैं लेता हूँ 2 minus 1, which is 1. But if I say 1 minus 2, then your answer is minus 1. That means I cannot subtract the number in any order. मैं subtraction को किसी भी order में subtract नहीं कर सकता हूँ. Same way if I go to the division, then definitely 20 divided by 5 I do, then I'll get the answer 4. But can I do 5 divided by 15 and will I get the answer same? Will I get the answer same? No, New is the first to answer. New, Kreet, then Priya is third to answer. Good, definitely. We will never get the same answer. The reason is what? That is 5 divided by 20, we will get 1 upon 4. And how can a 4 and a 1 upon 4 be the same? That's why I said that there is a true friendship. Addition with multiplication and subtraction with division. Same way in commutative property is what? That on the left hand side of the equals to. For example, if I say कि अगर equals to के पहले का जो नंबर है और equals to के बाद का जो नंबर है, वो दोनों ही साइड को, लेफ्ट हैंड साइड और राइट हैंड साइड को अगर मैं किसी भी ऑर्डर में ऐड करता हूं तो मेरा आंसर सेम आएगा. बट दैट विल ओनली कम इन द एडिशन एंड इन द मल्टीप्लीकेशन. जैसे कि मैं ले लेता हूं कि 3 plus 4 हो गया या 4 plus 3 हो गया, दोनों का आंसर हमें सेम ही आने वाला है. वैसे ही अगर यहाँ पे कर दो 3 into 4 12 और I can say 4 into 3, everything is same. This is called the commutative property, to communicate with each other. Yes or no? Are you clear with this? Are you clear? Yes. Joshi said yes. Okay. Thakecha Vraj says yes, yes, yes. Okay. Detroja, yes. Okay. Loading. What is loading? Okay. Done, done, done. Chal. Same way, now you only tell me what would happen with the subtraction and division. If I subtract the numbers in any order on the left hand side, and if I subtract the numbers in any order, matlab different from the left hand side, do I am going to get the answer same? Yes or no? Same as closer, okay. But do I am going to get the answer same? Fast everyone. No, no, no. No, not same. Very nice. No, okay. Fast. Good, very good. So if you are enjoying the lecture, hit the like button, because many are new, I can see. Many of the students are new, I can see them. Hit the like button. Fast, fast, fast. Yes, no, no, no. Now next question to you. Is it possible in the division? Is it possible in the division? Hit the like button. Is it possible in the division? Never, never. No. Arya said no. Then Parsana said no. Very good. Detroja no. Priya, Smith, Tulsi. Oh my God, messages are getting too fast. It's impossible to read. Great. So what we got it? What we got it from here? That we cannot subtract the numbers in any order. Same way we cannot divide the order in numbers in any order. Same way, coming to the last, associative properties, that is a plus b plus c equals to a plus b plus c. That means ab in the bracket and bc in the bracket. So just tell me, in addition, is it possible? In addition, is it possible to do so? Is it possible to do in addition? Yes. Sekaruddin, yes. Joshikrit, Marvin, Vrushika, Arya, Priya, Atif Ali, Meet, Bhakti, Smith, then Gondalia, Om, Faldu, yes, definitely, yes. Everyone is saying yes, yes, yes. Same way, you just tell me for the subtraction. Is it possible that I can subtract the any order, minus sign in any order, and we can get the same answer? No. Marvin is the first to say no. Then Swasti is the first. Priya, no, no, no. Very good. Zarna and everyone. Definitely right. Then moving towards the multiplication. Moving towards the multiplication. Now just tell me about multiplication. Fast. This question is more going to be based on the question answer. Q&A type. Yes, definitely. In multiplication, definitely we can multiply the numbers in any order, then also our answer is going to be same. Yes, many of them are saying yes, 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 definitely. Tulsi, Sekaruddin, then Mishri, Manthan. Okay, Manthan is also here. Yes, everyone is saying yes, yes, and yes, definitely. Chalo. Then what about division? Fast. Is it possible with the division? No, no, no. Dhwani said no, no. Man said yes, no. Very good. All our maximum students are saying no, no, no. Definitely no. So from here we come to know about the properties which are applicable under addition, subtraction, multiplication and division. Clear? So chalo, now definitely we will move. If you want to take a screenshot, then just take a screenshot. So definitely we will move with the examples. Few examples which we need to learn, that I will teach you. I have written, done, taken screenshot. Okay, Manmeet, taken screenshot. Yes, done. Sir, go ahead. Krit is saying fine. Yes, sir. So almost all I have taken the screenshot. Then let's quickly move towards the examples. Few examples we will take, and then we will move towards the linear equation. Chalo, now We will look after few of the examples of this chapter so that we could complete the chapter very quickly, and then we will move further with our next. To be very interesting fact that I should tell to you that today I had came early from the school. Actually the school was on, but still I thought that we should go live. So it was possible for me to do so. Very much enjoying Atif Ali. Okay sir, ek duster le lo please. But Krit, you should give the duster. Don't you worry that you should give the duster yaar. I never carry the duster. काले लेतो आओ, डेफिनेटली लेतो आओ, चलो. But see, I don't like carrying the dusters and all that anywhere. Definitely, if it would be a school, then definitely I would ask for the duster to you, that give me the duster, or I would just say that in this whole big class you don't have a duster. So the background music is very nice, so that you entertain. No, that's why I am here. So you are, chalo. Background music with the sir cloth. Now the watermarks are not visible. Yes, for that's the only main reason which I had gone with the cloth, because over there the Manthan is saying that this like a school, sir. So a celebration of background. Swasti, focus in the studies. Chalo. Now we will take up with the examples fast. We will directly go with the example 1, which is present on the page number 9. Example 1. Quickly we will do that. We have to find the value of 3 upon 7 plus minus 6 upon 11 plus minus 8 upon 21 plus 5 upon 22. So how we are going to see it? See, here this all the numbers are of addition. All the numbers are of addition. So what we are going to see, that we need in the addition or subtraction we need to make the denominator same. But here all the numbers are different. So we will collect the numbers such a way that which are the multiples of the number. Like if I say that 7 is the multiple, 21 is a 7 is a multiple of 21. Same way 11 is the multiple of 22. Can I collect them together? That 3 upon 7 plus minus 8 upon 21 plus minus 6 upon 11 plus 5 upon 22. So this is what I had rearranged the numbers. See this, the main sign of the question is addition, and I am rearranging the numbers. That means whenever I rearrange the number, my answer is not going to change. So it is going to be the part of commutative. Moreover, after rearranging, I am making a groups of it, and whenever I make a group, it is called the associative property. It is called associative. So over here in this question, we are using commutative as well as associative property. See, this is the actual use of the property which we had learned, that we can shift the fractions in any order, still it is not going to affect our answer. That's why it is called commutative. Moreover, we are making a brackets of it, so it is called associative property. That means commutative and associative properties are used under addition because main sign is addition. What would be the LCM over here? LCM is 21. Same way here the LCM is 22. That means 3 upon 7 we are going to multiply with 3 over here, and numerator also with 3, plus minus 8 upon 21 as it is, bracket over, plus minus 6 upon 11 into 2 plus 5 upon 22. So 9 upon 21 plus minus 8 upon 21 plus minus 12 upon 22 plus 5 upon 22. So what we found over here, that now we have made the denominator same. So 9 plus minus 8 upon 21 Same way, plus over here minus 12 plus 5 over 22. So when we solve over here, we will get 1 upon 21, 1 upon 21, then plus minus to solve the sum, that is 7, and the sign of greater number, minus 7 upon 22. So 1 upon 21 plus minus 7 upon 22. Now we will find the LCM over here. LCM is 462. Yes or no? What would be the LCM? 462? Yes, 462 would be the LCM. So when I multiply 1 upon 21 into 22 into 22 minus 7 upon 22 into 21 into 21. So we'll get 22 upon 462, then minus we'll get 14 and 7, 147 upon 462. So our answer is minus 125 upon 462. Did you got the steps how we did and why we have recollected? See, these are such a sums which you can solve without making the groups or without reshuffling the numbers, but you have to find over there LCM of all the numbers. But when I reshuffle it, someone has asked, Hetanshu has asked, why to take the commutative property? The reason is very simple. Commutative property means what? That we can add the numbers in any order. That means if I reshuffle the numbers from one place to another place, then also my answer is going to be same. That's the only reason, because commutative, moreover we had made the groups of it. Is it easy to everyone? Yes or no? Fast. Is it easy? Want to take a screenshot? Okay, let's move further. Take answer. Okay, let's move further. Chalo, now let's see the next examples. We are going to take examples over here and a few important questions if any comes across them. Badminton practice. Who is this badminton practice? Sir, at the last try to give some extra sums from your side. Definitely, sir, we want you in 9th also, Parsana. Okay. Takecha, Stavan. Okay. Badminton practice is Stavan. Yes, sir. Krit is right. Definitely. Definitely, we are going to see, for the extra practice, what happens? You know, that happens what? That you need an extra time. Right now, first make your basic concept clear, and definitely from the next SEM, we will be conducting this type of live sessions on every Sundays, most of possible. So we would be covering whole chapter. Moreover, I'll be giving you the extra questions. And objective series also we will bring in the SEM 2, so that your concept becomes the most strong. That's why. Chalo, let's move with the example 2. Example 2, that we have to find minus 4 upon 5 into 3 upon 7 into 15 upon 16 into minus 14 upon 9. Just make it your one thing very strong, that we are always going to see the main sign. Your multiplication is the main sign, and whatever property would be using over here, that would be under multiplication only. So over there in the addition, we collected such a numbers, how the denominators becomes easier for us to LCM it. Here we are going to make a group of such numbers which we can cancel them easily. Like here minus 4 upon 5, if I write with 15 upon 6, then I can easily cancel 5, 15 and 4 and 16, because in the multiplication we cancel the numbers. Same way into 3 upon 7 I will be writing with minus 14 upon 9. So 5 ones are 5 3s are, 4 ones are 4 4s are 16, 3 ones are 3 3s are 9, 7 ones are 7 2s are. So we got it here minus 3 upon 4 into minus 2 upon 3. So here also we can cancel 3 3 cancel, 2 1s are 2 2s are. So minus minus become plus. So our answer is plus 1 upon 2. So it is so easy for us to solve. Yes or no? Answer is 1 upon 2. Marvin is very active in answering. Yes, Tulsi, Radhanpura, yes, everyone, good. Devarshi, I think, Radhanpura, good. Here, Het is also here, okay. So if anyone is new, then hit the like button. If anyone is new, hit the like button. If you are new to the channel, because these videos have been spread out so long, so if you are new to the channel, then please hit the like button. Chalo, example 3 we will go with. Example 3 says that two upon 5 into minus 3 upon 7 minus 1 upon 14 minus 3 upon 7 into 3 upon 5. Over here one thing is very clear for you to understand, that whenever you find a multiplication, subtraction, then subtraction and multiplication, when you see more than one sign in the question, and especially if it's a multiplication or division, then the number which is present before multiplication or the number which is present after multiplication, or same way we will go with the division also, the number which is present before division and after division, we will make them in a group. So this is a multiplication sign, we will take the number before it and after it as a group, same way before and after as a group. Now from this both the groups, is any fraction same? Answer it fast. Is any fraction same over here? Is any? Yes, definitely. Minus 3 upon 7 minus 3 upon 7 minus 3 upon 7, definitely. So in this both the groups we are going to take minus 3 upon 7 as the common. So this minus 3 upon 7 we are going to take it as a common fraction, and from this bracket if minus 3 upon 7 we have taken out, then what is left out? 2 upon 5 we have left out over here, and from the another bracket what is left out? From the another bracket the left out is 3 upon 5, and in between we will have a plus sign, because this 2 upon 5 is having plus sign, moreover 3 upon 5 is having plus sign. So this way, and what is left out? This minus 1 upon 14 is left out, which will keep it at the last. So here minus 3 upon 7 bracket 5 as a common, 2 plus 3, which is minus 1 upon 14. So minus 3 upon 7 bracket 5 upon 5 minus 1 upon 14. 5 cancel, so minus 3 upon 7 minus 1 upon 14. We will take out the LCM of it, and what would be the LCM? LCM is 14. So this minus 3 upon 7 we are going to multiply with 2, and this also with 2. Same way minus 1 upon 14 with 1 and with 1, that means minus 6 upon 14 minus 1 upon 14. So minus 6 minus 1 upon 14 equals to minus 7 upon 14. 1 and 2. So our answer is minus 1 upon 2. Clear everyone how the answer has came? Yes. Mahi, Smith, Zarna, then Devarshi, good everyone. Marvin, Priya, yes, Hetansh, good. Sakaruddin, Manmeet, Tetroja, Pranav, Smith, Vishwam, Manthan, Rajiv, Dhakeja, Vraj, Dhwani, have you got 3 upon 5? When your answer is somewhat wrong, you will get it answer minus 1 upon 2 only. Raj is saying my doubt. What's your doubt, Raj? Chalo, so everyone clear? So here in this chapter, before ending up of this chapter, definitely we are going to clear once the identity. We are going to use the identity, that which is the identity, multiplicative identity and additive identity. We are going to take it as a part, and then we will end up with this chapter. So this chapter is not to be much of worried. You may get the questions either of, you won't be getting any 4 marks questions from this chapter. So don't worry about it. You may get objective types of questions, or the short 1 or 2 marks questions you may get from this. So let's go through the additive identity and multiplicative identity. Multiplicative identity and additive identity. Now it is a difference between multiplicative inverse and additive inverse. There is a huge difference. What happens in the here when I use the word identity, that means it shows that we are supposed to take such a number. We are supposed to take such a number, like for example if I say 4 upon 5, then this 4 upon 5 I have to multiply with which number to get the answer 1. Same way in the additive identity there is something different, that this 4 upon 5 I have to add which numbers to it to get the answer 0. Both has a difference. In the multiplicative identity we want such a number which we multiply with this to get answer 1, and over here the number which is that we are going to do the reciprocal of it, जो कि हमने 7th स्टैंडर्ड में सीखा था मल्टीप्लिकेटिव इनवर्स. हमने 7th में सीखा था मल्टीप्लिकेटिव इनवर्स. दैट वाज द पार्ट ऑफ द आइडेंटिटी. इनवर्स यानी कि उल्टा कर देना, तो 4 upon 5 तो उसका हम कर देंगे 5 upon 4. So 4 4 cut, 1 1 cut, so our answer is 1. Same way in the additive identity what we had learned, that we are going to go with the additive inverse. In inverse what we used to do with, we make the number as it is only. We write the number as it is only, 4 upon 5 as it is as 4 upon 5. But we always used to change the sign. This 4 upon 5 is having plus sign. So this 4 upon 5 will be having minus sign, and plus minus minus. So 4 upon 5 minus 4 upon 5 is equals to 0. That's why this is called the additive identity as well as multiplicative identity. In multiplicative identity we have no concern with the sign. We have no concern with the sign. We'll keep the sign as it is, same. Sign same. But numbers will be inverse. But what happened with the additive identity, that numbers will be same as well as sign will change. So this is only the main difference between that and multiplicative identity. Sign will remain same and numbers will be inverse, but in the additive identity, multiplicative identity, sorry, and in the additive identity the number will be same and sign will change. Chalo, so if you want to take a screenshot or write down, do it fast, so that definitely we will start with our chapter 2. So chalo, now let me drink water. For the objectives you can read the points of what we discussed. For the objectives you can read the point what we have discussed. But remember students, we have to create a history. You have to create a history this time. Remember that. Karthik is over here, taken screenshot. Okay, Devans, Kakadia Rushil, sir, okay. Identity and inverse is different. Yes, Hitan, so identity and difference is identity and inverse is different. Chalo, so let's start with the chapter 2. UTS Army will be best. Okay. Swasthi is telling UTS Army will be the best. Chalo, let's start with the chapter 2. 0 equals to 0, Utsav equals to hero. Oh my god. Krit, you have also started this all the things. That's nice to see. Don't delete. It is good to see that. Chalo, now linear equation. In this chapter, there is nothing too much to worry in this chapter. It is very easy chapters. We will take few questions and we will complete up in just a short time. And I had also, for the different types of questions, I also created a series of it so that you can watch that also. But right now we will stick to the textbooks so that you get the better idea. Chalo, let's start it with the example 1. Example 1 is 2x minus 3 equals to x plus 2. So 2x, now we will collect all the variables one side and the constant another side. So let's start it. Chalo, 2x, then this x we are going to shift it from the right hand side to this side, that is minus x equals to 2 as it is. This minus 3 goes to the right hand side, it will become plus 3. So we will get, what would be your answer? Yes, x, definitely x equals to 5. Very good. Marvin is the first. Chalo, now meanwhile in between I will be asking you the questions also. So focus over here as well as answer it. Example 2. Let's go with the example 2. Example 2 says that 5x plus 7 upon 2 equals to 3 upon 2x minus 14. So what we are going to do is, first tell me that how many fractions are there on the left hand side. Fast. How many fractions are there on the left hand side? Quickly answer it. 2. New is the first. Then Hetanshu, Krit, Atif Ali, Man, then Meet, Dholakia, yes, Mahi, Tulsi, everyone is 2, 2, 2. Now just tell me that how many fractions are there on the right hand side. Fast. How many fractions are there on the right hand side? 2, 2. Krit is saying 2, definitely. And now the next question which is for you, that is, are they individual? Are they individual or they are complex? Are they individual? Yes, Krit is the first. Swasti, you are wrong. Gondalia, you are right. Good. Meet, definitely, yes, individual, Neev is saying. Hetansu, it's not complex. It's individual. Definitely, it's individual. Yes, yes, yes. Lot of questions. Yes, definitely. Everyone is right. So, if they are individual, then we will collect the variables on the left hand side and constant on the right hand side. So, here in the left hand side, 5x is already here. This variable, we are going to take it to the left hand side. It will become minus 3 upon 2x equals to minus 14 over here, and then we will take this 7 upon 2 to the right hand side. It will become minus 7 upon 2. So here what would be the LCM over here? In the left hand side, what would be the LCM? What would be the LCM? 2. Okay, 2. Yes, right. Neev is right, Krit is right, everyone is right that the LCM is 2. So 2 over here as well as LCM is 2 over here. That means this 5 upon x upon 1 we have to multiply with 2, and here also with 2. Minus 3 upon 2x equals to minus 14 upon 1 we will multiply with 2 into 2, minus 7 upon 2. So 5 2s are 10, 10 upon 2, 10x upon 2 minus 3x upon 2 equals to minus 28 upon 2 minus 7 upon 2. So 7x upon 2 equals to minus plus, so it becomes minus 35 upon 2. So now we are having a single fractions on both the sides. Now we are having single fractions on both the sides. Definitely, Krit, we will cancel the denominators, but now we are having the denominators same, so we will cancel out the denominators and we will write the numerator as it is, that is 7x equals to minus 35. So x equals to minus 35 upon 7. 7 1s are, 7 5s are. So x equals to minus 5. Done? Very good. Oh my God. Everyone is answering before I solve. Great, everyone. But while learning or while studying, you just have a one focus in your mind that we are working hard for our history to be created. Remember that. Don't move or don't distract your focus. Chalo, then here the next is 6x plus 1 upon 3 plus 1 equals to x minus 3 upon 6. So I'll be taking few questions only from this, and then we will move further. The next example which we are going to take, that is, chalo, now let's start it. See here, this 6x plus 1 upon 3 is a complex one. So what happens if it's a complex one, that we cannot shift the variables and constants on either side. So we need to take the LCM over here only, that the LCM is 3. Same way the LCM is over here, that is 6 itself, so no need to take the LCM. So here 6x plus 1 upon 3 plus 1 upon 1 we are going to multiply with 3 itself, and here x minus 3 upon 6 as it is. So that means 6x plus 1 upon 3 plus 3 upon 3 equals to x minus 3 upon 6. So here 6x plus 1 plus 3 as a common equals to x minus 3 equals to 6. Now we are having here 6x plus 4 upon 3 is equals to x minus 3 upon 6. So here now we are having 1 now we are having 1 fractions on both the sides, 1 fractions on left hand side and 1 fractions on right hand side. And once we get the 1 fractions on both the side, then definitely we are going to cancel the denominators if it's possible. So here 3 1s are 3 2s are, that means 6x plus 4 upon 1 equals to x minus 3 upon 2. Now we will do the cross multiplication over here. Over here, that means this 6x plus 4 we are going to multiply with 2, moreover x minus 3 we are going to multiply with 1. So 12x plus 8 equals to x minus 3. So 12x minus x equals to minus 3 minus 8. So here we get 11x equals to minus 11. So x equals to minus 11 upon 11. So x equals to minus 1. Definitely right. Everyone's answer is right. X is equals to minus 1. Yes. Krishiv, then Gondalia, Kartiki, Marvin, Het, Priya, Man, Neev, Devarshi. Good. Mahi, Man, Sangvi. Definitely all are answering right. Very good, everyone. Oh my God, Kreet, nice to see you. That sir, you got the same answer as me. Oh my God, thank you. Actually, you know, Kreet, I came to take a tuitions from you. Thank you so much. But that's a part of a fun. Definitely, Kreet, you get the same answer because you are my student, and my students is always like me. What do you say? Yes or no? My students are like me only. Magnet brain. But there should be a one question I should ask to you over here. Kreet, are you still there with the MB, or you started with the UTS? What do you say? Are you still there with MB, or you started with the UTS? Kreet, UTS, Mathik fan, UTS, magnet brain. Het is telling magnet brain. A sir so wise, a guide so kind. Utsav sir we will always find. Oh my God, Hetans, good. UTS Zindabad, definitely. Chalo, let's move to the next example. I should really appreciate my students. You know why? Because most of the students, they run away from the maths, and on the holidays I am coming live for you, and you people are showing a great enthusiasm for the studies. Thank you for that once again to everyone. I really appreciate it. Thanks to all that on this holidays also you all are here with me. Thank you, everyone. This shows that you all have started learning maths and you enjoying it. And do you know, this is the only reason why I started the why I once again been active on the YouTube. This is the only reason, because I want to remove that hateness about the maths from you. You all should start loving math. And I really proud of you that you all are my members of UTS Army. Thank you. 1 hour completed. Okay, let's move. This is the last example of our chapter 2. So here this 5x will become as it is. This minus 2 is going to be used as a distributive property. So 2 2s are 4x minus 2 plus 2 minus plus minus 2 7s are 14 minus minus plus. Be very careful. Be very careful. Be very careful with the signs, please. 2 3s are 6x, 2 1s are 2, minus sign in between, plus 7 upon 2. Now we are having 3 fractions on the left hand side and 3 fractions on the right hand side, but that all the fractions are individual fractions, so we can collect the variables one side and the constant another side, which is equals to minus 2 plus 7 upon 2 minus 14. So now chalo quickly answer fast. 5x minus 4x. 5x minus 4x. What is it? Fast. Quick. 5x minus 4x, x. Yes, definitely. Neev is the first to answer. Then second in first, x. Everyone, yes, x. Rushika, x. Now this is a x. So this x minus 6x. What would be the answer? X minus 6x. Minus 5. Priya has answered minus 5x. Definitely. Minus 5x equals to minus 2 plus 7 upon 2 minus 14. Now we need to take the LCM on the right hand side. What would be the LCM? 2 over here also. Create new. Yes, everyone is answering 2 definitely. So your LCM is 2. And if LCM is 2, then here we are not going to disturb anything. Minus 5x as it is, minus 2 upon 1 plus 7 upon 2 minus 14 upon 1. So this we are going to multiply with the 2 to make our denominator same. So minus 5x equals to minus 4 upon 2 plus 7 upon 2 minus 28 upon 2. So minus 5x equals to minus 4 plus 7 minus 28 upon 2. So minus 5x equals to minus 4 plus 7. What would be the answer? Fast. Minus 4 plus 7. Minus 4 plus 7. You all are giving the correct answer, that is 5 upon 2. But right now I want the answer minus 4 plus 7. 3. Then 3 minus 28. 3 minus 28. 3 minus 28. Minus 25. Yes. Create first. Minus 25 upon 2. So now if we see over here, minus 5x equals to minus 25 upon 2. So this x equals to minus 25 upon 2, and this 5 we are going to take it to the downside. 5 1s are 5 5s are minus cut, so x equals to 5 upon 2. Clear? So our answer is 5 upon 2. Yes, Kartiki, yes. Marvin, definitely right. Neev, everyone right. Exact answers. 5 upon 2, 5 upon 2, 5 upon 2. Sir, 50 plus views. Yes, Krishu. Definitely 5 upon 2. Chalo, so this is clear to you. So here we end up with our chapter 2 also. So here this type of questions would be there. You need to be very careful with the sign. And remember, in the exercise I make you mark 2-3 questions as a star question. Do you remember that star question? Over there you oftenly make a mistake. So anyone is new who has came late, so please hit the like button. In this live session, what is the one important thing and interesting thing? Do you know, students, which I like most, that many of the students are from the starting of the live sessions. That's cool enough. Most of the students, not many, but most of the students this time are from the starting of the live sessions. That's cool enough. Good. Okay, chalo. Chalo, now we will move towards our chapter 3. Our school, Einstein, Marvin is saying, Sir, I was from first, but I was not chatting more. I know that man, our school. Chalo, let's start with our chapter 3. Open up the chapter 3. I'll be asking you the few questions and you have to answer that. Are you ready for that? Yes, chalo. Tell me what is called the polygon. What is called polygon? Tell me what is called polygon. These are the questions which I am going to ask, which is going to be the part of your closed figure. Okay. Many sides. This is the right answer, Jarna. Many sides, Priya. Many sides, Man. Closed figure. Definitely it's a closed figure, but polygon means which has a many sides. Yes. Closed figure with lines. Swasti is sharing. Okay. Shape with many sides. Arya is telling closed figure. Okay. So definitely if I talk about what's a polygon, then it is a closed figure made up of many line segments, or you can say a closed figure which is made up of many sides. This is known as a polygon. Then what is a concave and convex polygon? First of all, explain what is a concave polygon. Many sides. Aryan Mundwa is over here. Okay. Now tell me what's the convex polygon. I had already explained you convex polygons. Vertex makes line, lines makes line outside. Okay, Krit, more better answer you gave. It does not have any sides out of the shape. Okay, that's also the logical which I had explained you. Closed figure, yes. Vertex makes line outside. Okay, that's called the convex polygon. See, this is very important to understand convex polygon and concave polygon. What is convex polygon and what is concave polygon? Convex polygons are such figure whose vertex points outward, that are called, it does not have joining points out of the shape. Okay, this is the actual word, that the convex polygon are such polygons where vertex points outwards. That means if I take a rectangle, then these corners are called my vertex, and this all the vertex are pointing outward direction. None of the points are or vertex are pointing inside. So these are called spatial reasoning lectures. Okay, the line formed outside the line, vertex makes line outside. Kartiki, definitely vertex makes line outside. Yes, so this is what convex polygon means, the vertex which points outwards, that is known as a concave polygon. Same way if I talk about concave polygon. Now what is this concave polygon? Concave polygon means the vertex which points inwards. Now what is this inward? That for example, if I am drawing one figure over here, and you can see that this all are the vertex which is pointing outside, but this is one of the vertex which is pointing inside. That means the vertex which points inward is known as a concave पॉलीगॉन. कॉनकेव, केव मीन्स गुफा आप कह सकते हो. क्या गुफा के अंदर अगर कोई जाता है डेट इज कॉल्ड कॉनकेव पॉलीगॉन. गॉट इट? कॉनकेव पॉलीगॉन गुफा. केव यू कैन से. इफ एनीवन गोज इनसाइड इट, गुफा के अंदर हम लोग जा सकते हैं. दैट मीन्स द कॉनकेव पॉलीगॉन इज सच अ पॉलीगॉन वेयर वर्टेक्स गोज इनसाइड टू इट. दैट इज कॉल्ड द कॉनकेव polygon. Same way convex polygon means the points which moves outside it, that is called convex polygon. So very simple step to make you remember that is very simple, that the concave polygon means cave means गुफा और गुफा के अंदर जाए, यानी कि जो वर्टेक्स जो कि अंदर की साइड आता है उसको हम कहते हैं कॉनकेव. और कॉन्वेक्स पॉलीगन मीन्स द पॉलीगन विच गोज आउटवर्ड, that is known as a convex polygon. Clear everyone? So those who are new, hit the like button fast. Good. So is it easy? Now you won't be getting any confusion between convex and concave polygon, because concave means what? Cave means गुफा, गुफा के अंदर जाना, यानी कि मतलब कोई भी वर्टेक्स जो कि अंदर की साइड आता है उसको हम concave polygon कहते हैं. Very easy way to understand concave polygon. Yes, yeah. Thank you so much. Good. So chalo, let's move for the 70 minutes on, sir. Thank you. But students, you know, as I told you in the class that the place where I shoot, this is not the luxurious place. Do you remember? I told you that here it does not have any fan, any tube light or anything. This is one of my best friends' place where I am doing this, all the things. And I don't have any connections over here, fan or anything, but still I am always doing for you the best things so that you can learn and our target can be achieved. So just no offense. Yes, Sabarmati, Ahmedabad, UTS Zindabad. Definitely hard working, sweat on shirt. Yes. Okay, you can see the sweat on my shirt? Sir, you told us. Yes. Thank you, sir. You are doing this much for us. Definitely, students. This is the only reason, because you are showing me the great efforts. That's why. Thank you, sir. You are doing this for us. We can see you are sweating for us. Thank you. Inspiring Alak Pandey. Definitely. Here, this is C. See, for the definitely over there also in the physics wala you might have seen that the Alak Pandey is working so hard only for the students, and one day he got the success, and for behind that success the first batch of the tuition class, you might have seen that physics wala web series. Over there also it has been shown to us that one of the batch from the tuition classes has supported that sir a lot, and I am definitely proud that that batch I had got from this school, and definitely you all are there with me, and I will also be one of the famous teacher where you all love is going to be shine like anything. Thank you so much for all this. And I still remember Heth has told me that I am going to be that Shivani who is there with the sir. Definitely Heth. And I really hate, see, this is not so that that you only, I only teach us. Many times what happens that the students also teach us. Definitely, of course, sir. Chalo. Now, listen over here, students. Before starting this chapter is somewhat lengthy enough. Moreover, in this chapter, in the properties, I have created one small 3 letters word. I have created a small 3 letters word just for you to remember all the properties of all the quadrilateral figure. I had created 3 letter word which will show you, or which will help you out to recall all the properties of a quadrilateral without remembering anything. You just only have to remember the figure, and all the properties will be in your hand served like anything. So that property, that shortcut I am going to teach you, but sorry, I won't be teaching you right now because it's too hot in this room, and You can see my situation, it's too hot. So sorry for that. I told you that I will be covering chapter 1, 2 and 3 all, but 3 will take a long time, and the time is also going to end up at 1:30. So definitely I am sorry that I could not start up with that, but we will. Chalo, so definitely we will keep it till over here. In the next sessions, most probably on the Sunday we would conduct. So in that we will be covering a long topics over there and long chapters over there. So is it fine? Is it okay that I keep it till here, or we want to continue as you say? Okay sir, no problem. Okay. So chalo, just let me show you the room which I was talking about. So are you all ready to see the room where I am shooting out? I have no fans or anything, but this is all for you. So keep your support on. Are you ready for that? Yes, chalo. Keep it till here. That I will say it. Super 30 is taking tuitions from Utsav sir. Oh my God, thank you. Chalo, let's have a look. Okay, just hold on. See, you can see it over there. Yeah, no fans are there, nothing is there. No lights, no fan, only for you. You can see nowhere the lights or anything is there. Room tour, okay. Definitely. You can take it as a room tour, but it's for all for you. Did you see that? Windows, please. You want to see the window? Oh my God. Chalo, let us take. See, these are the two huge windows you can see over here. But definitely these windows are there, but without the fan or anything, it is not possible to stay or sustain, because the direct sunlight is coming inside the room. So that is also one of the strongest part. On Sunday, turn on AC. How should I turn on AC? No fans, no light. Very nice suggestion. I think it's a Godan because I see shutter. No, this is not a Godan. Actually, this is my friend's tuition center from where I am conducting these live sessions. So this is one of the extra room which is kept for the upcoming more batches. That's why. So finally, we will keep it till here and we'll meet on the Sundays. Are you ready for the Sunday? Yes or no? Yes or no? Hard working sir, thank you. Okay, Parsana is crying, don't cry, but see my situation, it's not so well. So we will keep it till here. Thank you everyone. Bye bye everyone. I know you are going to miss me. Gondolia is crying. Okay, Vrishika, yes, thank you. Thank you everyone. Bye everyone. Take care. We will meet on the Sunday. On this normal day, I would like to share one thing, special thing. Thanks for struggling so much for us. We are really lucky to have a teacher like who supports this. I think Swasti is there. Okay. Thank you so much, Swasti. And we should actually thanks to everyone. Chalo. So we will keep it till here. Bye everyone. Thanks. Have a nice day. Before leaving, hit the like button. If you are not hit, then. Chalo. Bye bye everyone.